Welcome to this specialized training module on business resilience. Today, we are moving beyond simple backups and disaster recovery to the strategic core of resilience, the business impact analysis, or BIA. Before you can decide how to recover, you must know what to recover and when. The BIA is the diagnostic tool that tells us which parts of the organization are critical to survival and which can wait. Let's dive in. Let's start by establishing the context. Business resilience ensures the organization's ongoing viability and survival in the event of a major disaster. While we often hear about disaster recovery, which focuses on IT recovery, and business continuity, which focuses on business processes, neither can exist effectively without a business impact analysis. Think of the BIA as the blueprint. It helps us distinguish between what is merely annoying to lose versus what is fatal to lose. The BIA identifies critical business functions and workflow, determines the qualitative and quantitative impact of a disruption, and prioritizes recovery objectives. If you skip this step, you are essentially guessing at your recovery strategy. This mind map visualizes the ecosystem of business resilience. At the top, we have the overarching goal of resilience. This splits into two arms: business continuity planning, BCP, which focuses on keeping business processes and revenue alive, and disaster recovery planning, DRP, which is the technical restoration of IT systems. Sitting at the foundation of both is the BIA. As you can see, the BIA feeds the goals of identifying criticality and prioritizing recovery into both BCP and DRP. You cannot build the top layers without the data from the BIA at the bottom. How do we actually conduct a BIA? It is a structured process. We start by gathering data, often using questionnaires or interviewing key users and business process owners. We ask them, what do you do? Who relies on your output? And what happens if you can't do it? This leads to the identification of critical functions and resources. We must verify this data. Users often overestimate their own criticality. We then establish recovery times, determining exactly when a disruption becomes a disaster. Finally, we define recovery alternatives. Can this process be done manually? For how long? This analysis provides the data needed to justify the budget for recovery strategies. This flowchart outlines the BIA lifecycle. We begin with data gathering, utilizing interviews and questionnaires. This inputs into identifying critical functions. Note that we must also determine resource dependencies. Processes don't run in a vacuum. They need servers, people, and buildings. This leads to the analysis phase, where we branch into two tasks: establishing recovery times and defining workarounds. All of this consolidates into the final BIA report, which will guide our strategy. Not all business processes are created equal. In the criticality analysis, we classify systems based on their tolerance to disruption. Critical functions are those that, if lost, threaten the immediate survival of the business, like an e-commerce storefront. These usually have a tolerance of minutes to hours. Vital functions might be handled manually for a short time, perhaps 24 hours. Sensitive functions, like billing, might wait 72 hours, though it is painful. Non-critical functions can wait weeks. It is vital to note interdependencies. A non-critical server might actually be critical if a critical application depends on it for authentication. This chart visualizes criticality based on impact and tolerance. Look at the top right, critical. These systems have high impact and low tolerance for downtime, like e-commerce. They need immediate attention. Moving left, vital systems have high impact but slightly more tolerance. Sensitive systems in the bottom right have lower tolerance but lower impact. Finally, non-critical items like archiving are in the bottom left, low impact, high tolerance. We focus our budget on the top right quadrant. The BIA yields two absolute metrics: RTO and RPO. You must know these for the exam. RTO, or recovery time objective, is the clock. It specifies the maximum elapsed time to get an application back online after a disaster. If your RTO is 4 hours, you must be up and running 4 hours after the crash. RPO, or recovery point objective, defines data loss. If your RPO is 4 hours, you are saying, we can afford to lose the last 4 hours of work. These metrics drive cost. A 0 RPO and 0 RTO require expensive real-time mirroring. A 24-hour RPO only requires a daily backup. Visualize the disaster on a timeline. The event happens in the middle. Looking backward into the past, is the RPO how much data, work in progress, did we lose since the last backup? Looking forward into the future, is the RTO how much downtime passes before the system restores complete an operations resume? The gap between the backup and the disaster is your data loss, RPO. The gap between the disaster and resumption is your downtime, RTO. RTO and RPO are not the whole story. We have the MTD, or maximum tolerable downtime. This is the absolute ceiling. If you are down longer than the MTD, the business fails. There is also WRT, work recovery time. Once the servers are up, RTO, the staff still has to rekey lost data and catch up on the backlog. Therefore, your RTO plus your WRT must fit inside your MTD. We also define the Service Delivery Objective, or SDO. This defines the level of service we can offer during the disaster. Perhaps we can process 50% of orders manually while the systems are down. This Gantt chart illustrates the formula MTD equals RTO plus WRT. The disaster strikes at 0-100. The blue bar is the RTO, the technical work to get systems online. It takes 4 hours. But we aren't done. The purple bar is the WRT, the business catching up. That takes another 2 hours. Business fully resumes at 6 o'clock. This is safe because our MTD limit, the red diamond, isn't until 8 o'clock. If the bars extended past 8 o'clock, the business would fail. How do we measure the impact? We use 2 methods. Quantitative analysis deals with numbers and dollars. We calculate the single loss expectancy, SLE, and the annual loss expectancy, ALE, to determine exactly how much a disaster costs per year. This helps justify the budget for controls. However, not everything has a price tag. Qualitative assessment uses rankings like low, medium, and high. It measures intangibles like loss of goodwill, customer confidence, or employee morale. You generally need both. Quantitative numbers to satisfy the CFO, and qualitative scenarios to understand the reputational damage. This diagram shows the 2 branches of impact analysis. The quantitative class focuses on hard numbers, financial data, SLE, ALE, and ROI. The qualitative class focuses on soft metrics, scenarios, reputation, and rankings. Both inherit from the main impact analysis process and are necessary for a complete picture. It is crucial not to confuse the BIA with the risk assessment. The risk assessment identifies threats, like hurricanes or hackers, and vulnerabilities. It asks, what is the likelihood of this happening? The BIA, on the other hand, assumes the disaster has already happened. It asks, how bad is the impact and how fast must we recover? Ideally, the risk assessment helps prioritizing the BIA efforts, but the BIA focuses on the criticality of business processes, not the specific nature of the threat. The BIA tells you what to save. The risk assessment tells you what you are saving it from. Here we see how the 2 processes converge. On the left top, the risk assessment identifies threats and likelihood. On the left bottom, the BIA identifies critical processes and impact metrics like RTO. Both of these streams flow into the strategy selection state on the right. You cannot effectively select controls or a recovery site without inputs from both the risk assessment and the BIA. Finally, what is the output of the BIA? It drives the recovery strategy. If the BIA says you have a 1-hour RTO for a critical process, you must choose a hot site or a mirrored solution. If the BIA says you can wait a week, a cold site is sufficient and cheaper. The BIA prevents you from overspending on non-critical items and underspending on critical ones. We perform a gap analysis to see if our current capabilities meet the RTOs defined in the BIA. This leads directly into the development of the detailed business continuity and disaster recovery plans. This flowchart shows the decision logic. We start with the BIA results, RTO/RPO. We enter the evaluation decision. If the RTO is low, requiring speed, we must select a hot site, red. If medium, a warm site, yellow. If high, we have time, a cold site, green. All paths lead to the final step, developing the specific BCDR plan. The BIA dictates the path we take.